So here's looking at you, kid. Next to me, you'll see like this giant bug thing. I want you to look at those eyes. Oh, those eyes. Those ones staring right into your soul. And I want you to tell me everything you know about those eyes. Today we're looking at writing compound inequalities. Well, writing and graphing compound inequalities. And sort of the unwritten statement in there is that while we are writing and graphing these things, I really want you to understand what they are and what they mean as well. So in order to really get this, we need to take a look at what an inequality is. And an inequality, every time, just describes a range of numbers. So for example, if we take x is greater than 5, and I put this on a number line, like this, I'll just put a 5 in the middle. I have told you that what I do is I shade in, and I'll use a different color for this, is I shade in all the solutions kind of like that. And so when I talk about x being greater than 5, that means all of the x's bigger than 5. And so it's literally an infinite number of numbers. Everything bigger than 5 is what I'm talking about. So this whole inequality right here is just a clever way to talk about altogether all the numbers bigger than 5. That's really what the inequality does. What we want to change, however, is what if I'm interested not in just all the numbers bigger than 5, but let's say all the numbers between 5 and 10. What if I just wanted that and I didn't want all of this part over here? The question is, how would I write that? And the way I do this is with something called a compound inequality. So a compound inequality is what we use when we want to describe a range between two numbers. So for as just an example, let's say we want to talk about all the numbers between 5 and 10. So we're going to use x to describe those values. We know that x has to be bigger than 5. So let's say 5 is less than x, but at the same time, it has to be true and x has to be less than 10. Those two things have got to be true at the same time. We can actually write that just like I did there. So there are two ways to do this. The first one is to use the word and. When we say this inequality and this inequality, what we're really talking about is the space between those two numbers, provided we have our symbols meaning that as well. There's another way to write this. Notice how there's an x in both of those. I can also write this by saying there's the 5, there's the 10, there's the x, and just putting those symbols all smashed together into one statement. This statement says that 5 is less than x, but x is less than 10. And so there are two different ways to write this. I can write this in this form right here, where I have two inequality symbols in the same statement, or I can write it as two separate inequalities linked by the word and. These are called compound inequalities, and the reason they're called compound inequalities takes us back to our bug eyes, which I'm sure you were just hoping that I forgot. The eyes on this bug are what are called compound eyes. And if you've ever tried to swat a fly, you know it feels like they have a sixth sense, like they know no matter where you're standing compared to them, they know you're coming. And the reason is these compound eyes. If you look, each one of these little tiny dots is itself an eye. And so these insects will have, between tens and hundreds of eyes pointed in every direction, and their brain will take all of the input from those eyes and make one image so that this creature can almost see 360 degrees around it. So these compound eyes are eyes that are made of lots of little bitty eyes put together. When we talk about our compound inequalities, what we're looking at are more than one inequality, see there's one, there's two, put together. So just like compound i's are multiple i's put together in one, compound inequalities are multiple inequalities put together in one place. So we saw in this example that an inequality can be used to describe the space in between two numbers. In fact, if I were to graph this, it would look something like this. I'd have 5 here on this end and 10 on this end. I'll use a different color to talk about this. I'd put a circle around 5, a circle around 10. X has to be greater than 5, but at the same time less than 10. And so what we've done is we're now talking about this range of numbers in between 5 and 10. Well, we can use a compound inequality to talk about that range of numbers, or we can use a compound inequality to say that that range of numbers cannot be x. So for instance, let's take a look at this one. What if we wanted all the numbers, all of them, every single one of them, except the numbers between 0 and 7? So what we're kind of shooting for here is if this was our number line, and this was 0 and this was 7, what we want is we want to take all the numbers, so we're shading in everything except that area in between them. And so before we were talking about just the area in between, now we're talking about not that area in between. And so when we go to write this, what we can say is that if we just look at this part over here, x has to be less than 0. We could also say that x has to be greater than 7, and it's either one or the other, so we would say or in between them. Just like in a compound sentence, you have and or in between them. In a compound inequality, you can have and or. So x is less than 0 or x is greater than 7. And that was maybe a poor choice of number. Those look similar. But that is x is greater than 7. And so we can see that in our graph, that we're talking about everything except the area between 0 and 7. And in fact, we can write that out in our other way as well. We've got two x's here. We've got 0 on one end, we've got a 7 on the other. And we know that x has to be less than 0, and it has to be greater than 7. Excuse me, greater than 7. And so I can write this compound inequality this way, or using an or statement. So I have two different types of compound inequality. I have one that talks about the space in between the two numbers, which we call an and type inequality because we join them with the words and. I can also have an inequality where I talk about everything except the space between two numbers, and I call that an or statement because it is either on one side or the other. Can't be both, can't be in the middle. So now let's just look at all the examples of this. Example 1 asks us to graph this inequality. -9 is less than x, which is less than or equal to -7. So let's start with just this part. -9 is less than x. So I'm going to put a circle around -9, and I know that x, my shaded region, has to be bigger than that. Well, let's put that on the back burner for a second. Let's look at the other side. X also has to be less than or equal to -7. So I'll take a -7. X can be less than that, or it can be equal to that. So I would shade in my circle as well. And now I can see that this is an and statement talking about all the numbers between -9 and -7, but including -7. And so notice what I did really was just took 1/2, graphed what that meant, then took the other half, graphed what that meant, and put them together. Just like a compound I, as many small i's put together A compound sentence is multiple sentences put together. A compound inequality is just two or more inequalities written together. And so here I'm talking about, again, the range in between those two numbers. Let's look at another. Here we're graphing the inequality -5 is greater than x, which is greater than -1. So I'm going to again start with my points of interest. So I have -5, and x has to be less than -5. The duck's mouth is eating -5, so it's bigger, so I would shade this way. And x has to be greater than -1, put a circle around -1, x is bigger than that. And here I can see that this is an OR statement. We're talking about all the numbers except the ones in between -5 and -1. In this one, you can kind of tell right up front it's going to be an AND statement. There's a clue there in the middle if you didn't catch it. So let's go ahead and graph this, but we know since it's an AND statement, it's going to be talking about the space in between these two numbers. So we look at -6, and we look at 4, and just from knowing the definition of an AND statement, we know we're going to fill in this gap in between, but let's still look at it in terms of the inequalities. K is greater than or equal to -6, so I have to shade in greater than, and I have to shade in the equals to portion. And over here we have 4 is greater than K, that is K is less than 4, so I would shade this way. And I have my AND statement talking about all the numbers between -6 and 4 and including -6. So let's look at an OR statement for that. We have P has to be greater than 10. So I put a circle around 10. It's an OR statement. So we know we're talking about all the numbers except a section in the middle. And P has to be less than or equal to 8. So that's going to be all of this section right here. And since it's equal to, we have to fill in that dot as well. And now we can see we're talking about all the numbers except the ones between 8 and 10. So again, specifying this range and then deciding how that applies to my situation. Now another thing I can do is go the opposite way. I can write a compound inequality from this. And technically speaking, if I just give you this problem, you can write it either way you'd like to, or you'd like, using two inequality symbols mashed up together, or if you wanted to use the AND OR statements. Either one is fine. For this example, I'm actually going to do both. Again, you don't have to do both. You can pick your favorite and go with it. But I'm going to go ahead and do both. Looking at this, we know this is an OR statement because we're talking about everything except the numbers between 5 and 10. And so I'm going to write over here that this is totally going to be an OR statement, and then I'm going to fill in what I know over here. So I know that x has to be, in this case, less than 5. So I would write that x is less than 5. It's not equal to because that's not filled in. Or, over here in this case, x has to be greater than 10. And so here is my compound inequality. X is less than 5, or x is greater than 10. Now I can also write that a second way using just one variable and multiple inequality symbols. I'm going to put my x in the middle. I'm going to put 5 over here and 10 over here. And now we just described the relationship. X has to be less than 5. So 5 has to be the bigger of the two. And 10 has to be greater than x, so x has to be the bigger of the two. And so either one of those is an acceptable way to write that inequality. For this one, we can see that this is an AND statement. I'll do the same thing where I write it both ways. Since I know it's an AND statement, it's talking about the space in between, I can go in here and I can say that x has to be greater than -2. Or if I look at my other side, x has to be less than or equal to 5. And now I have my compound inequality. I can also write it over here with one variable. I'm talking about the space between -2 and 5. X has to be bigger than -2, but it has to be less than or equal to 5. So notice we've got all the same relationships here. It's just written in two different ways. So these are compound inequalities, which let us talk about the range in between two numbers, and we can either select that range using an AND statement, or say we want everything but that range using what's called an OR statement.